Hi everyone! In today's video we are going to do a little bit of review of exponent rules from Algebra 1 and then expand that to get to some Algebra 2 content. Today you're going to learn how to manipulate and simplify rational numbers with exponents. So rather than just having an integer in your exponent, we're going to have a fraction, a rational number as that exponent. So let's look at some examples reviewing from Algebra 1 and seeing the commonalities to Algebra 2. Okay, so first, in Algebra 1, you learned that if you had two bases that were the same, that were being multiplied together, that you could add together the exponents. So if you had x squared times x to the third, that was the same as x to the 2 plus 3 power. And so you could simplify it and say that that is x to the 5th power. In Algebra 2, you are going to have the same rule, but we are going to have to deal with fractions now. So if we have x to the half power times x to the 1/3 power, because the bases are the same, that is the same as x to the 1/2 plus the 1/3 power. We're going to come back to that in a moment. I want to do a little bit of reviewing of operations with fractions before we finish that, but we are not done with that problem yet. Okay, so let's go back to our rules and kind of go through all of these, and then we'll do some fraction work. So for the power rule with integers in Algebra 1, you learned that if you had a base raised to a power, and then that entire quantity was raised to another power, that you could take those two exponents, the 2 and the 3 in this case, and multiply them together. So that would be 2 times 3. And 2 times 3 is, of course, 6, so that simplifies to x to the 6th power. That same rule is going to apply when we have fractional exponents. In this problem below it, we have the base of x, and the power of 1/2 is going to be multiplied with the power of 1/3, because that is a power being raised to another power. Again, we will come back to simplifying that further once we've done some fraction review in a moment. The distribution property says that if you have multiple bases being multiplied together, and that's a really important distinction here. It has to be multiplication. We're not talking about adding or subtracting here. Then we can take a power that's on the outside of the quantity, in this case the 4, and distribute it to both bases, the x and the y in this case. So we're still using that power rule, which means we're multiplying. We're doing the x with that square multiplying with that outside power, and y is also a base in this one. That exponent is a 1, so we're multiplying it by the 4 as well. So that means we have x to the 8th and y to the 4th power as our simplified expression there. That same rule applies when we have rational exponents as well. So we have two bases, the x and the y. The x has a power of 1/2, and we're going to use that distribution and power rule to multiply by 1/4. The y has an exponent of 1, and we're again going to multiply by 1/4. Again, we will simplify this a little more in a moment. Okay, so the negative exponent rule that you learned in Algebra 1 said that if you have a base that's raised to a negative power, we need to, in order to simplify, get rid of that negative that's in front. And the way that we do that is by flipping the base with the power to the other side of the fraction bar. So if I just write up here for just a second, do you agree that, let's use a different number. Let's use 5. 5 is the same thing as 5 over 1, right? We can write it like that. So that means x is the same thing as x over 1. We can write it as a fraction. So if I put this x to the negative 2 power over 1, so that I have a fraction now, the negative exponent rule says that I'm going to flip this. These two pieces are going to go to opposite sides of the fraction bar. So the one that's on the bottom in the denominator is going to move up to the numerator, the top, and the x to the negative 2 is going to move down into the denominator, but that negative is going to go away. So it's just going to be x squared. Notice that the only two things that changed is that the sides swapped and the negative went away. It became positive. And this will work both ways. So if I wanted to move this x squared up to the numerator so I didn't have a fraction anymore, I could swap and move it up to the other side of the fraction bar, and it would become a negative 2. I also do want to point out in a few minutes that really the only thing that changed here is that the numerator of x to the negative 2 moved down into the denominator. This could have been written as 1 times x to the negative 2 all over 1. The 1 didn't really move. It was already here because it's a separate base. And we'll get into that when we have other numbers there because they'll look a little bit differently. So please excuse my kind of basic understanding that wasn't quite mathematically correct. It was for the sake of simplicity here. That will complicate things a little bit later if you don't think about the swap being of moving that x to the negative 2 only, technically. Okay, so looking at the rational exponent, we have a negative 1/2 there. The same thing is going to apply. We are going to move the entire base to the other side of the fraction bar, so it's going to be down in the denominator now. And the power, which was a negative 1/2, is now going to be a positive 1/2. We are going to simplify this further, but we are not going to do that today. We're going to do that in the next video. We're going to work on just getting these 5 rules down pat before we work on simplifying things like that further. So this one, for right now, for today, is done. Okay, so the last rule that we have is the quotient rule, and it's pretty similar to the power and the distribution rules. This time, though, rather than having the x and the y both in the numerator, I have the y down in the denominator. That distribution rule is going to apply here too as a quotient rule. So in Algebra 1, you learned that if you had a fraction, we could take the exponents and again use that power rule, multiply them together. But because it's a quotient, we're going to do it to both the numerator and the denominator. So in the numerator, we have 1 times 2, and our denominator's base, y, has an exponent of 1, so we're going to multiply that by 2 as well. So that means then that we have x squared over y squared for our final answer there. The same thing applies with your rational exponents. So in our numerator, we're going to have x to the 1 times 1/2, and in the denominator, we're going to have y to the 1 times 1/2. Again, it's kind of like distributing that power of 1/2 to both sides of the fraction. We do need to simplify this one a little bit further because of that multiplication. Okay, so now let's review operations with fractions so that we can go back and then finish all of these Algebra 2 style problems. All right, so first let's review multiplication. In multiplication of fractions, you learned in elementary school that you multiply the numerators, you multiply the denominators, and then you simplify. So in this problem, 1/5 times 3/4, we're going to do 1 times 3 for our numerators and 5 times 4 for our denominators. So that's 3 over 20, which doesn't simplify any further. So we're done there. Division, you are going to rewrite it as a multiplication problem where we do a keep, change, flip. So we're going to keep the first fraction the same. We're going to change the sign to be a multiplication sign. And we're going to flip the second fraction to be the numerator and the denominator, opposite from how it was originally. And then this is just a multiplication problem. Now in this one, I do see some factors that are going to factor out. So rather than just multiplying across the top, because then I'd have to do a bunch of simplifying, I'm going to go ahead and do my simplifying now while my numbers are small because it's going to make it easier. So what I see here is 5 and 6 don't simplify and 9 and 2 don't simplify. But because this is multiplication, 9 and 6 are both divisible by 3. So if I divide out that factor of 3, 9 divided by 3 is 3, and 6 divided by 3 is 2. So that leaves me with 5 over 2 times 3 over 2. And now I don't have any other factors that will divide out. So when I multiply across, I get 15 over 4. And that doesn't simplify any further. That is fully simplified. So that is going to make it a little bit easier for me if I take the time to do that factor and divide out step. So let's take that multiplication and division and go back to these problems before we go any further. So this first problem has addition, so we're not going to worry about it just yet. The second problem, though, has multiplication. And we just learned that to multiply fractions, you multiply the numerators and you multiply the denominators. So we're doing 1 times 1 up top and 2 times 3 in the denominator. So that's x to the 1 over 6th power. Next class, you're going to learn more how to simplify this, but for right now, that is a simplified answer. Okay, let's look at the distribution problem. This one also has multiplication, so we're going to do the same thing with it. For the x, we're going to multiply the 1 times 1 and the 2 times 4. Multiply your numerators, multiply your denominators. For the y, 1 is the same thing as 1 over 1, so I'm going to do 1 times 1 and 1 times 4 there. Okay, so then let's keep going with that, simplifying it to finish up. I've got to change my pen color again. Okay, so to finish up, that's x to the 1 over 8. Y to the 1 over 4. Again, next class we'll have more to do with those fractions, but for now we are done. Okay, the last one that we can do right now just with multiplication is the quotient rule, because I have these numbers that in the exponent that need to be multiplied, and I have some in the denominator's exponent as well. So I'm going to have x to the 1 over 1, right, because that's 1 over 1, times 1/2. So that means I'm going to have 1 times 1 and 1 times 2 in my numerator, and then down in my denominator I'm going to have, again, that's 1 over 1, 1 times 1, and 1 times 2. Okay, so then my final answer for now is going to be x to the 1/2 over y to the 1/2. We will do more next class, but for now we're just going to try to get to that step there. So the only other problem that I haven't finished simplifying all the way from the Algebra 2 style problems with rational exponents is this one with the plus sign. So let's review that really quickly. We'll do one addition and one subtraction, so you've got it both ways. They're pretty similar. Okay, so you have to have a common denominator whenever you add and subtract fractions. So the way that you probably learned this initially is that you multiply each denominator by the other one. So if this is 3 times 7, or so 3 divided by 7 and 2 divided by 3, the one with the 7 in the denominator, I'm going to multiply by 3 over 3 because of this denominator. And then I'm going to multiply the one on the right, the 2/3, by 7 over 7 because of that denominator. Now, what that's going to then do for us is it means that we have, using our multiplication rules, 3 times 3 is 9 over 21, added to 14 over 21. Now, because I have common denominators, I can add together just my numerators. My denominator is going to stay the same through the rest of the problem. So 14 plus 9 is going to give me 23. And I'm going to leave these as improper fractions. That is okay. That doesn't divide any further. Nothing divides out and simplifies, so I'm all done there. Now, this does work always, but it is not the fastest way always. And the second problem, the subtraction, is a good example of that. I have a 3 and a 9 in my denominator, and I want to have common denominators, but what I really want to have is a least common denominator. Because if I have a least common denominator, I won't have to keep simplifying after I do my subtraction or my adding, whatever the problem is. So what I notice here is that 9 is the same thing as 3 times 3, and 2/3 already has one of the 3's in the denominator. It's almost the same as this 5 over 9's denominator. So I'm only going to multiply by 3 over 3, because in that one on the left, when I do that multiplication, 3 times 3 is 9. And what that will then mean, if I multiply on top 2, is that without having done anything to the 5/9, I now have a common denominator of 9. And I'm not going to have to do extra fraction simplifying work afterwards. I can just subtract my numerators and get 1/9, and I'm done. If you opt to continue using that method on the first one where you just multiply by the other one, look at what's going to happen. If I do 2/3 minus 5/9 and I multiply by 9/9 on this side and 3/3 on this side, then I get 18/27 minus 15/27. And 18 minus 15 is 3/27, but you're not done yet because you have a factor that divides out. 27 is 3 times 9, and this fraction is not simplified because those 3's divide out. That leaves you with 1/9. So if you want to do it without the least common denominator, you'll get to the same place, but you have to be really careful that you don't make a mistake in that step there when you get the 3/27. If you use the least common denominator, you don't have to worry about that at all. Okay, so let's go back and finish up this last problem. This one, our denominators are 2 and 3, and there's no common factor there, so we're going to multiply 1/2 by 3/3, the other denominator, and we're going to multiply 1/3 by 2/2. So we're doing this multiplication, and we're doing this multiplication as our next step. Multiplication with fractions just means multiply across the top, multiply across the bottom. So that is x to the 3/6 plus 2/6 when I multiply across my tops and bottoms. Now I have common denominators. That's good. It means I can do the addition part now. I can add together my numerators, the 3 plus the 2. So that gives me 5 on my numerator, 6 on my denominator, and now that I've added those together, I'm done. All right, or at least for now. Okay, so now that we've seen a couple of examples for each of those 5 different rules, let's just do a quick recap, a couple of important things. Number 1, you must have the same base before using the rules. Notice that on this one that had, or these 2 that had x and y, I didn't then combine these exponents because these bases, x and y, are not the same. They would have had to be the same base, both x's or both 5s or something like that. They'd have to match. The other rule that is really important that we haven't talked about yet is that if x or any number is raised to the 0 power, it's just equal to 1. It's super easy, just a quick little thing to memorize. Okay, so you have a recap here of our rules. Notice you have when your bases are being multiplied, that means you add. When you have a power raised to a power, that means you multiply. We talked about distribution when it's only multiplication inside. If you had a problem like this versus a problem like this, those are 2 different things. This one is the distribution rule. This one is distribution, but it's a plus b times a plus b, which means that you have to do that distribution where you're foiling. So we have to go a times a is a squared, a times b is ab, then we do our inner distribution for ab, and we distribute that last piece to get b squared. These 2 things are not the same as one another, so be really careful with that sign. This is a multiplication rule, not a binomial rule. Okay, so then you have your negative exponent rule, where that part moves down to the other side of the fraction bar. We haven't talked about this one in a lot of detail yet, but basically if you have 2 bases that are the same, we did the quotient rule with the different bases, you can subtract the exponents, and that will get you to your simplified piece. So let's actually do some examples now, because some of these get a little bit complicated, and I want to show you lots of examples to get you ready. Okay, so this first one, I have the same bases, base is 5, and I'm multiplying the two expressions together, or two terms together. So that means I am going to add the exponents. The base of 5 in this one is not going to change. The base is still just going to be 5. Don't multiply your bases together. So I have 5 to the 3 halves. Again, I'm adding here because it was that multiplication problem, which means that I have common denominators already. That's good, so I can just add my numerators. 4 over 2, and then that fraction simplifies because 4 divided by 2 is just 2, and 5 squared, that simplifies a little more to 25, and that's my final answer. The second problem is a power raised to a power, so that means I'm going to multiply. I'm going to do x to the 2/3 times 1/2, which means I'm going to multiply my numerators and multiply my denominators. Final answer for this one is 2 over 6, but that fraction simplifies further because these are both divisible by 2. 2 divided by 2 and 6 divided by 2. So we're going to take out that factor of 2. Another way that you might think about this is 6 is 2 times 3, which means that's going to divide out. And it leaves us with 1x raised to the 1/3. And that's my final answer there. Okay, in this next one, I have a negative exponent, so I'm going to deal with that first. Notice that this is a fraction bar here. We have 9 to the first power being divided by that 9 with the negative exponent. So I am going to move this denominator up to the top of the fraction bar. I'm not doing anything with that 9 to the first power yet. I'm only moving the part with the negative exponent to the other side. So I'm going to move it up top, and the only thing that's different is that 4/5 is now a positive 4/5. There's nothing else in the denominator, so this is technically all just over 1 now. I'm not going to write that because who wants more fractions than you need? Okay, so I have two bases being multiplied, which means I am going to add the exponents. That's 9 to the 1 over 1 plus 4 over 5. My common denominator here is going to be 5, so I'm going to multiply the 1 over 1 by 5 over 5. You could multiply this by 1 over 1, but it's not going to change anything. So that means that we have 9 to the 5 over 5 plus 4 over 5. Adding fractions means that you add the numerators and leave the denominator the same. Okay, let's look at another one, this time with some variables. We have two bases that are the same being multiplied, so that means we add our exponents. That's 1/8 plus 5/6. This one we do need to find common denominators for. And these are both divisible by 2, so I'm going to find the least common denominator. 8 is 4 times 2, and 6 is 3 times 2. So I don't want to just multiply these together. I want to do some thinking here. So when I think about 8 and 6, 8 times 3 is 24, and 6 times 4 is also 24, and those numbers match. So I am going to multiply the one with the 8 as a denominator by 3 over 3, because that's going to give me a 24 in the bottom. And I'm going to multiply the fraction with the 6 in the denominator by 4 over 4, because that's going to give me a 24 in the bottom of that one. So I'm going to do 3 over 3 times 1/8 and 5/6 times 4 over 4, and that's going to give me a denominator of 24 in both of them. So I'm going to have my least common denominator. My top is going to be a 3, and then I'm going to do my adding in my next step. 5 times 4 is 20. So my denominators are common, and that means I can just add my numerators. And that does not simplify anymore because I use the least common denominator. So that one is done. All right, moving right along. Notice in number 5 that these two bases are different. There's a 5 and an x. So I am not going to put these two together. I'm not going to multiply them. It's not like in number 1 where both of the bases were the same. So I'm not going to worry about that multiplication sign. I'm going to worry about this power of 3 on the outside. The distribution property says that I am going to write my base with my fractional exponent, and then I'm going to multiply by the exponent, the power being raised to a power, and that is the same as 3 over 1, so I'm just going to write that so it looks a little bit neater. And then my x to the 1/4, it also gets a distribution to multiply by 3 over 1. So now when I simplify, I get 5 to the 3 over 3, which is just going to be 1, and x to the 3 over 4. So 3 divided by 3 is 1. That's 5 to the first power, so I'm just going to write a 5 and leave the 1 to be understood. And then x to the 3/4 power. Okay, the next one, when I look at it, I immediately see that I have a fractional exponent. So I'm going to move it to the other side of the fraction bar first. This is all on the numerator side of the fraction bar. So I'm going to create a denominator, and then I'm going to put 2 to the 6th times 4 to the 6th, all raised to the 1/6 power on the inside, or on the bottom, excuse me. And then, because these bases are not the same right now, I'm going to deal with that distribution power, that 1/6. So I'm going to distribute it, which means I've got 2 to the 6th times 1/6, and I've got 4 to the 6th times 1/6. I'm going to put both of these over 1, so I have fractions, and then I'm going to multiply straight across the top and straight across the bottom. That's 2 to the 6 over 6 times 4 to the 6 over 6, and 6 over 6 is just 1, so that's 2 to the first power times 4 to the first power, and 2 times 4 is easy. That is just 8 for our final answer. Alright, so if I can get my computer to cooperate, we'll do just a couple more of these slightly harder ones. Okay, so number 7 is two bases that are the same, and this was that rule that I didn't do one of the Algebra 1 examples of. The 10 in the top has a first power for its exponent, and the rule says that if you have the same base on both sides of the fraction bar, you can subtract the exponents. So this is the same as 10 to the first power minus the 2/5 power. And then I can use my fraction rules for operations with rational numbers to simplify. So my common denominator, because this is a 1 over 1, is going to be 5, which means I'm multiplying the 1 over 1 by 5 over 5. And I'm going to leave the 2/5 because it already has a 5 in the denominator. So I've got 10 to the 5 over 5 minus 2 over 5, and 5 minus 2 is 3, so that's 3, and I keep my denominator the same, and that's all I can do for today. All right, let's do another one of those. Now this number 8 is almost the same problem. It just has x's instead of 10s. I'm going to do it the same way. The x in the numerator is a first power, so that's x to the first power minus 2/5. That 1 is like a 1 over 1, so I have x to the 1 over 1 minus 2 over 5. My common denominator, my least common denominator, is going to be 5. So I'm going to multiply by 5 over 5 just on the 1 because this one already has it. So I have x to the 5 over 5 minus 2 over 5, and 5 minus 2, just my numerators here, is 3. I keep my common denominator the same. And for today, that one is done. All right, now this last one, number 9, looks like a mess, but it's actually the easiest problem on the page. this quantity, the 46 times x to the third times x to, or y to the 23rd, is all raised to the 0 power. Recall from those rules that you have up at the top of the page, any quantity raised to the 0 power is just equal to 1. So this entire quantity, when I raise it to 0, is 1. And I'm done. All right, so today you learned how to manipulate and simplify rational numbers with exponents. Go ahead and give those Now You Try problems a try. We will talk about them in class.